So let's go through a little bit more of our discussion on how we can use right triangle trigonometry to help us solve certain kinds of problems. And here's a classic kind of problem that we deal with. Let's say we're told theta is an acute angle of a right triangle for which cosine of theta is equal to 4/7, and we're asked to find each of the following: the tangent of theta, the cosecant of theta, and the sine of theta. All right. Well, a picture is worth 1,000 words in trigonometry, so let's go ahead and just get a nice picture of a right triangle here to help us categorize and solve all our problems. So here's a triangle for which the cosine will equal 4/7. So let me see if I can get something that looks sort of 4/7-ish here. Let's write this in. Okay, so we've got this right triangle, and we've got in our right triangle here, there's that superfluous line here. Come on. Okay, in our right triangle, we have an angle theta. There it is. For some reason I'm getting my eraser symbol when I didn't want it. So in our right triangle, we're asked to solve. We're given cosine being 4/7. Well, what does that mean? That means where our adjacent side is 4, and our hypotenuse length is 7. Aha, you say, that looks familiar. That looks like one of those right triangle dealies that we were dealing with before. So yes, we've got a side B that we don't know this time. And so we're going to have to go about our Pythagorean theorem formula a little bit differently. Remember that the square of the length of side A added to the square of the length of side B would be equal to the square of the length of side C, our hypotenuse, and right here, at least as far as we're concerned, our lengths for A and C are given this time, but not length B. Well, let's fill in with what we know. 4 squared plus B squared would equal C squared, which is in this case 7 squared. So putting in a few numbers right here, 4 squared is 16 plus B, trying to make my B look 6-ish here. 7 squared is 49. I have to do a little bit of subtraction this time, so let's subtract 16 from both sides. 16 subtracting gives us B squared equal to, let's see, 9 minus 6, that's 3. 4 minus 1, that's 3. If we want to find B, we have to take the square root on both sides to get rid of that square, and so B would be equal to the square root of 33. All right, so I'm going to draw that into my picture here now, square root of 33. And now I actually have a visual image that I can use. For example, if I'm asked to find the tangent of the angle theta, what I'm really after is the ratio of my opposite side to adjacent side. On my opposite side, we now know to be the square root of 33, and our adjacent side to be 4, so there's our ratio for tangent. Cosecant is the ratio of the sides hypotenuse to opposite, right? Good. So now let's take that and do a division right here. Our hypotenuse side was 7. Our opposite side was the square root of 33, so we can write 7 over the square root of 33, and that's our answer. Sine? Well, sine was nothing more than that reciprocal of that cosecant. It's the opposite over the hypotenuse, and in this case, our opposite side has a length of 33. Square root of 33 divided by a hypotenuse of 7. More in the next section.